Still on the journal. The first journal entry we had this quarter was conic sections, then topics of calculus. So on this third blank page, we're going to do some derivative examples.
So for our first derivative example, we have y equals 5x cubed. The derivative, y prime, you do the exponent times the leading coefficient. That's going to equal 3 times 5 is 15. X, and then you subtract 1 from that 3. So 15x squared is the derivative. The derivative of e to the x, again, I'm going to use different derivative notation. dy dx, the derivative equals, and this is a little strange, it's the same thing. It's one of the few items where you take the derivative of the function and you get the function back. This one, there's a move to. I don't want to do all the rules for it, so there's a little move. So d dx, another way to say that you're taking the derivative, equals. All you got to do is write down a 2 underneath the fraction bar, and then copy that down. Square root 5x cubed. And now you might be wondering what goes on the top. And what goes on the top is the derivative of 5x cubed. So the derivative of 5x cubed is 15x squared. The derivative of ln x, a way to put it is big D, little x. The derivative of ln x, and this one you're supposed to memorize, is just 1 over x. The best I can do to help you memorize it is to cross out the n, and it looks like 1 divided by x. Now we're going to do some trig derivatives. The derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of negative sine is negative cosine. And the derivative of negative cosine, it loops back onto itself as sine. So on the way down, these are derivatives. Now they're called antiderivatives if you go on the way up. And that uses an integral symbol. Other zippy quick trig derivatives is secant, secant, tan. So if I were to ask you what the derivative of tangent was, your answer would be secant, secant, or secant squared. If I were to ask you what the derivative of secant was, your answer would be secant tan. Cosecant, negative cosecant, cotan. So the derivative of cosecant would be negative cosecant, cotangent. And the derivative of cotangent would be, because a positive times a negative is a negative, it would be negative cosecant cosecant or negative cosecant squared.
So we have conic sections, topics of calculus, derivative examples, and now the next page, we're going to do rules of derivatives.
So the first rule we learn of derivatives is called the general power rule. The easiest way to go into it is to first do an example. So if I have y equals 5x to the 7th, the general power rule to find the derivative is to take that 7 and multiply it by the 5. So 7 times 5 is 35. X, and then to the power, you take that 7 and you subtract 1. So 7 minus 1 is 6. And that's it. That's called the general power rule. Now the note on that is if you have ax to some power of n, the derivative is going to be that n times n times x, and then you take the n and you subtract 1 from it to the n minus 1 power. And that's the note. The second rule of derivatives is called the product rule. And that's if you have some function, one item u times another item v. And the note is this: y prime is going to equal u times the derivative of v, u dv, plus v times the derivative of u. So an example of this would be y equals e to the x times x to the fifth. I'm going to label this one as u. I'm going to label this as v. I'm going to crack it down the middle like an egg. Now the derivative of e to the x, the derivative of u, is e to the x. The derivative of v, x to the fifth, is 5x to the fourth. And I'm just going to use my move, u dv. So u times the derivative of v, this is dv, and this is du. So u dv is going to be e to the x times 5x to the fourth plus, notice there's the plus sign, v du. X to the fifth times e to the x. Third one is called the chain rule. The chain rule, that's where you have a function inside of a function. So if y equals f of g of x, what we do is we take the derivative of the outside and then multiply it by the derivative of the inside. So the derivative of the function would equal f prime of the same function times the derivative of the guts, g prime of x. This one is way easier to do with an example than it is to do with the note. So here's an example. If I have y equals 3 times 5x to the 7th plus 2x to the 5th power. Looks really complicated, but we're going to implement the chain rule. So we're going to do the derivative of the outside. That's the f prime of x. So 5 times 3, that's going to give me 15. And then I just copy this down, 5x to the 7th plus 2x. And I subtract 1 from that 5 to the 4th power. And now I have to take the derivative of the guts. So the derivative of 5x to the 7th is going to be 35 x to the 6th, and then the derivative of 2x is 2. But I have to multiply the whole quantity by it. And that was an example of the chain rule.